In this example, we're told that we have a circuit here that is delivering maximum power to the load R. We found in the previous example, assessment problem 4.21, that the power delivered to the voltage to the load was 60 volts were being delivered, and that the current being delivered to that load resistance was 20 amps being delivered. And that gave that load a output of 1,200 watts. And now we're being asked about the power being delivered by the 100 volt source, the power from the dependent source, and the overall efficiency of this circuit. So we were able to find these values in the previous problem where the load was connected to a Thevenin equivalent circuit. And that worked to tell us what's happening on this side, what's happening to the load, and all of these values that were happening when the Thevenin equivalent circuit was connected, these values are still true now. But if we want to find the power delivered by these sources, the total efficiency of the circuit, we have to look at this part of the circuit as it is here, not as a Thevenin equivalent circuit. And so if we're being asked about the power being developed by voltage sources, we know the voltage, we're going to need to know the current passing through that voltage source so that we know the power being delivered in each case. If we're trying to find currents here, the thing that makes the most sense would be to use nodal analysis. We can use the ground as our zero. Then we'd be at 100 volts here because we'd be going from 0 up a 100 volt source, so this would be 100. If this is 100 and we go up V phi, then our voltage here would be 100 plus V phi at this node there. Those are all technically supernodes. This is 0, we go up 20, so this is 20. We go up V phi again, so our voltage here would be 20 plus V phi. And then we know that the voltage here is 60 volts because this was the voltage across the load when the maximum power was being delivered. We found that again in the previous problem. So here, we can imagine we're going to have current flowing here. We can imagine we're going to have current flowing there. And we know the current passing through the load, again, from the previous question. So we can do a KCL equation looking at these currents, and we can try to figure out what V phi is and what the rest of the currents are in this circuit. So I'll start by writing a KCL equation for this node.